UBTech achieved the world's first successful deployment of multiple humanoid robots working together across various scenarios and tasks, carried out at Zeekr's 5G wired smart factory in China. The achievement marks a significant step in robotics, showcasing advanced coordination and adaptability in diverse environments. In January, the company unveiled plans to mass-produce its Walker S humanoid robots, targeting 500 to 1,000 units by year-end for industrial applications. UBTech's BrainNet framework enables effective humanoid-robot collaboration by linking cloud device inference nodes and skill nodes, forming a superbrain and an intelligent subbrain within its swarm intelligence system. The superbrain uses intelligent hybrid decision-making to handle complicated production line activities, driven by a big reasoning multimodal model. Based on a transformer model, the intelligent subbrain combines multi-robot control and cross-field fusion perception, enabling simultaneous distributed learning to speed up skill transmission and generation. These developments enable humanoid robots to cooperate on jobs other than isolated ones, guaranteeing smooth production line teamwork. This skill propels the development of intelligent manufacturing and improves efficiency in industrial settings. UBTech has created the first major reasoning multimodal model for humanoid robots in the world to satisfy the decision-making requirements of intricate production lines. As the superbrain's core, this AI system enables BrainNet's continuous self-evolution, maximizing swarm intelligence potential. It is developed with DeepSeek R1 deep reasoning technology. It processes large-scale data to equip robots with human-like common-sense reasoning. This allows autonomous task scheduling, breakdown, and coordination, optimizing multi-robot collaboration. UBTech's multimodal reasoning model is trained on a high-quality industrial dataset gathered from real-world practical training with Walker S robots in multiple automotive factories. By integrating multimodal features and leveraging retrieval-augmented generation technology, the model adapts rapidly to specialized job functions, significantly improving decision-making accuracy, generalization across various workstations, and scalability for large-scale industrial deployment. UBTech's humanoid robots have entered practical training 2.0, advancing from single-agent autonomy to swarm intelligence. At the Zeekr 5G intelligent factory, dozens of Walker S1 robots now operate in key production areas, including final assembly, SPS instrumentation, quality inspection, and vehicle assembly. These robots collaborate on sorting, handling, and precision assembly, demonstrating seamless multi-robot coordination in industrial environments. Walker S1 robots monitor dynamic targets and optimized sorting tasks in collaborative sorting by using clever hybrid decision-making and pure vision-based perception. In order to integrate a multimodal reasoning model with semantic VSLAM navigation and agile manipulation for cloud device decision-making, their swarm collaboration is based on collective mapping and shared intelligence. UBTech created a joint planning and control system for collaborative handling that takes environmental adaptation, trajectory planning, and load distribution into account. With the help of this technique, robots may dynamically modify their force and position, increasing stability and productivity when moving large objects. Walker S1 robots handle deformable materials in precision assembly by modifying their grasping force to avoid harm through the use of high-precision sensors and adaptive control. In industrial applications, their agile robotic hands improve dependability and flexibility. Walker S1 integrates vision-based global positioning with force-based secondary positioning via reinforcement learning, enabling precise and adaptive quality inspection.